Okay, here in the middle of page 10, we have another configuration to write that's actually even shorter than noble gas configuration. Please make sure you write down this blue stuff. I would recommend you also write down the red stuff because it'll really help your future self and maybe even your current self remember what we're talking about here. Now, valence electrons. You've probably heard this word before, but it's probably been a minute. These are the outermost electrons in an atom, the highest energy level of electrons. And if you remember, these configurations, as much as we talk about them like they're directions, they're not directions. Elements don't have houses. They don't live on the periodic table. This is just an analogy that helps us understand what we're doing here. But when we write out terms like 4s2, that big 4 in front of the letter, or whatever the number is in front of the letter, represents the energy level that the electrons are on. So our valence electron configuration is only going to include the terms that are on the highest energy level, which means we're going to be looking for the biggest of those big numbers in front of the letters and only including whichever terms are in that highest energy level in our configuration. Now, the easiest way to find those highest energy level electrons is to look at the full configuration and just look for those biggest numbers. So I've written these out here for you. I'm not sure if you have space in your packet to write out the long way and the short way, but if you do, it might not be a bad idea. Because all we're doing is looking at these coefficients, the numbers in front of the letters, and asking ourselves, well, what is the highest energy level? What is the largest number in front of the letters in aluminum? And for aluminum, the highest energy level is the third. And we actually have two terms here who both have some third energy level electrons, the 3s2 and 3p1 terms. So both of those are going to be in our valence electron configuration. And that's all that we got to keep. No noble gas, no extra stuff, just 3s2, 3p1. For beryllium, the highest energy level that we get to is the second energy level. And there's only one term there in that second energy level, so that's all that we bring down, 2s2. That's it. I did shorten down tin and iron into their noble gas configuration here, just because they're a little bit long, and the great thing is, the noble gas configuration, while it makes it short, will always include the terms that have our valence electrons. So it's always a good option if we're trying to look for this valence configuration. And if you notice in tin, we have the fifth energy level is our highest energy level. We drop down into the fourth energy level a little bit in between, but we do have two terms here that are both in the fifth energy level. So we bring both of those terms and only those terms down into our valence configuration for tin. With iron, our highest energy level we get to is the fourth, and so we bring that 4s2 down, and that's it. Now, if I had told you that, oh, I have an element with some configuration 4s2, you might think that I left off some of the beginning part, but you probably didn't think I could leave off some of the end part. And if I said, oh, something's at 4s2, you might think I'm talking about calcium, but I'm not. This is iron's valence configuration, but it is exactly the same as calcium's valence configuration. For that matter, scandium through zinc would also, that first row of the D block, would also have a valence configuration of 4s2. So these are not unique to different elements. In fact, this helps us see some of the similarities between different elements. And if they have the same valence configuration, some of them are going to act and react in a very similar way. So this is not something we can use to identify an element, because once again, it's not unique, but it can help us understand some of the chemistry of our elements. Now, we don't have a ton of practice. Oh, that was just a big long example to show you that process. But we don't have a ton of practice with these, but there on page 14, question number 18, you have some valence configurations that you can write.